This is Year 10 solutions video for homework 3. Question 1. A intersect B is the name for that first symbol there. That's the intersection symbol. Now that means and if you say it as a sentence. So let's say it. A and B. Everything that's in A and B. Just colour that middle section in there. Part B. In words. There's a little symbol here that you can use the word not when saying a sentence. So everything that's not in the middle. We've decided this means middle. So everything that's not in the middle. So that would mean colouring everything in on this diagram, like this. But not the middle. Part C. Well, A union B means colouring in the circles. That would be A union B. But actually there's a little not symbol there. So I don't want to do that. I want to do the opposite of that. So it would be everything that's not in the circles. So actually it's this section around here. Everything that's not in the circles. Because A union B means the circles. Part D. Get rid of that. On to part D. Everything that's in A, but not in B. That's that section there. And I can't include this section here because that section there is in B. So that's not allowed to be there. That leaves it looking like that, and that's the right answer to D. And then the worst bit on this page here is this bottom question. A union B intersect not A intersect B. Now that sounds ridiculous when you say it like that, but if we split it up into sections we can do this. A union B means the circles. So everything in the circles and... Now we decided this means not the middle. We decided that up here. So let's say it again. Everything in the circles and not the middle. Okay. Looks like that. Just make sure you don't colour the middle in. On to question 2. This is a lowest common multiple question. You know that whenever you've got a worded question about when buses or trains are arriving at the same time, you need to work out what's called the LCM, the lowest common multiple, and you do that using primes. Prime factor tree for 40 and 42. Let's start with that. 40. 4 times 10. Circle any primes that you see. There's 2 primes. There's 2 more. 5 times 2 is 10. Those are the primes for 40. Now we need the primes for 42 as well. So let's do that. We've got 7 times 6. There's a prime. And then that's 3 multiplied by 2. So those are the primes for both numbers. Now they go into a Venn diagram like this. On this side I'm going to have the primes for 40. And on this side the primes for 42. So let's just make a note of which side's which. Any primes that are shared go in the middle. So let's look for shared primes. Well, there's a 2 that's shared, so that's going in the middle. There aren't any more shared ones. So let's finish off the diagram now. Anything that's left on the 40 side, we've got 2, 2 and 5. 2, 2 and 5. Anything that's left on the 42 side now, 7 and 3. There they are. Now to find the lowest common multiple, once they're in a Venn diagram like that, you multiply all the numbers together in the diagram. If you do 2 times 2 times 5 times 2 times 7 times 3, you get 840. And that's actually the number of minutes before the buses are in the bus station at the same time. And there's a whole class misconception here. Quite a few people went wrong here, so it's worth making a note of this on your feedback sheet. That is the number of minutes until they arrive at the same time. But the question asks for the time there. So I need to convert 840 minutes into a time, or certainly into a number of hours, and then add it on to find out when it is. So let's do that. 840 divided by 60 is going to be 14. So that must be 14 hours. Now if I add 14 hours onto 10 AM, I get the time midnight. And that's probably the best way to answer it, because some of you wrote 12 AM, some wrote 12 PM. There was some confusion over which to write. Personally, I'd write 12 midnight, or you might want to write 24-hour clock. 0000 is another way of writing midnight. On to the next question. The number of elements in the universal set, so that's what part A means. Now the universal set is basically the rectangle, so I could actually label that up here if I put that little xi symbol there. So the number of things in the rectangle, if I count them, 1, 2, 3, 4, 5, 6, 7, 8, there's 9 things. That's easy. Now part B, there's actually a set of items, so I need to use little set brackets. Everything that's in the intersection is this little middle bit, so I want everything in the middle. And I'm going to write that as a set. 1 and 4 are things in the middle, using set brackets as a target. Part C highlights what this N symbol's about, the number of things in the middle. Now if you count the number of things in the middle, there are 2 of them, so that shows you the difference between when you're asked for the set of things that are in the middle or the number of things that are in the middle. It's not the same question, be careful. Part D, the number of things that are in either the A circle or the B circle. So basically the number of things that are in this section here that I'm colouring in, and if you were to count them, there are 8 of those things. And then finally, I want a set again, a little set bracket. The set of things that are not in the circles. Now, the things that are not in the circles is actually just this one thing here, 11. And then close your little set bracket. Those set brackets are missing on some of your work. Also, some of you have just used traditional brackets. So, for example, if I was to write it like this, 11, I've just got that question wrong. You've got to use set brackets. Watch how you do them. So it's a little curved bracket like that, the number 11, and a little curved bracket like that. They do take a little bit of practice. The first one I've drawn is a little messy there, but it's good enough. Right, on to the next question. Naming shapes. This is a nightmare for some of you. I'm going to name them now. Shape A, rhombus. Shape B, kite. Shape D, you can say arrowhead. You can't say arrow, and you can say its proper name, delta. That will get you the marks in the exam. D and E are about counting the sides. So let's do that now. I need to see how many sides there is on D. 1, 2, 3, 4, 5, 6. It's got 6 sides. So it's some kind of hexagon. You would be best saying irregular hexagon. Now E, one person did say it was a crown. That's not a mathematical name for a shape, so it's definitely not that. I need to count the sides. 1, 2, 3, 4, 5, 6, 7 sides. Now 7 in maths is hept. Hept. Agon. And you don't tend to do septagon. Some people have written that. It's best saying heptagon. And then finally, shape F, more traditionally drawn like this. You would recognise that straight away as a trapezium. Its main characteristic is this pair of parallel sides. If a shape's got 4 sides and a pair of parallel sides like this, then it is a trapezium, including if it's drawn how I drew it like that. On to the next question. This is the most difficult topic for the group. It's all about finding square number factors. The biggest square number factor of 200 I can think of is 100. Now that works because 100 times 2 is 200, so it's definitely right. And the square root of 100 is 10. So you actually end up with 10 root 2, which is the answer to the question. And if we do the same thing on part 2, 16 times 5 is 80, and the reason I picked 16 is because it's the biggest square number that I can think of that will divide into 80. Root 16 is 4, so the answer is 4 root 5. Now to answer part 3, you need to see a connection between parts 2 and 3. Part 2 says root 80. Part 3 says 3 root 80, so it must be 3 lots of my previous answer. And of course, 3 times 4 is 12, so the answer is 12 root 5. On to rationalising, and we're nearly there with this homework now. Multiply the top and bottom of the fraction by the denominator. So let's do that now. Times by root 5. Must do the same under here as well. Times by root 5. Now that means my answer is going to be 1 times root 5 on the top, and root 5 times root 5 on the bottom is just 5. So you end up with root 5 over 5. That's not so bad. It's this next one that's a problem. I'm going to multiply the top and bottom of this fraction by root 2. Now I'm actually going to write it in front like this, you'll see why. Root 2, and then I'm going to put some brackets in there. It's a bit messy that, right? Root 2. I'm going to multiply root 2 by the whole numerator, and I'm going to multiply root 2 by the whole denominator. Now the denominator is easy, it's just 2. Now using your expanding brackets techniques that you've got, that times that is 2 root 2, and that times that is 2. So you end up with that answer, 2 root 2 plus 2 over 2. And that is not quite finished, but it'll do. I would have given the marks there. You can simplify that to root 2 plus 1, but it's a little bit beyond the scope of what we've been doing in class. And then finally, collecting. You can't collect these together until they match. And at the moment we've got a root 27 that I don't like the look of, so I'm going to turn that root 27 into, well, let's do the 4 first. Root 27 is actually root 9, root 3, because 9 times 3 is 27. And root 9 is 3. So actually this bit at the beginning means 4 times 3. So you end up with 12 root 3 if we tidy that up. So that's 12 root 3. Now you're adding 12 root 3 to these 5 root 3's here. So your final answer is going to be 17 root 3. And you cannot do that question unless you change the surds so they match. On to the final question. Now that's the homework done. The last thing I'd like you to do on your feedback sheet is try this challenge. So if we look at this challenge question, now if I make up a question that will simplify, like this, watch, root 80 plus root 125. Now the reason that will simplify, let me just type that right. The reason that will simplify is because it's possible to turn them both into the same type of surd. I'm going to answer this one for you. What I'd like you to do is find your own question that will simplify. So watch me simplify this. I know that root 80 is root 16, root 5, and root 125 is root 25, root 5. And the reason they will simplify is because these surds at this side match. So you end up with a final answer of 4 root 5 plus 5 root 5. Now the question is, can you think of your own? Now you'll know if you've got this right because you'll start off with a pair of surds like that have got different numbers. But you should be able to simplify them through like I've done. I've ended up with 9 root 5. So you should be able to simplify your surds into the form a root b if you've found an appropriate question. Now one way to find a question is just to make one up, which would mean possibly starting here. And if the surds at the end match, in my case root 5, you could use a different number. If they match, you should be able to build a question that works. That's the challenge. Have a go at it and see if you can do it. Come and see me if you get stuck with that. That's it.